Okay, so we're kind of doing some of these problems to review a little bit for the end of course exam. So today, Monday, May 6th, we just did, I did this problem and then I had the class do this problem. So systems of equations, when we talked about for a long time how you can't solve an equation that has two variables if there's only one equation. You need the same number of equations that you have variables. So here we can do that. And in a system of equations, we're looking for the value of x and y that works in both equations, that makes both of them a true statement. So what value of x and y would make this negative 12, and what value of x and y would make this equal negative 24? So there's a bunch of different ways to do this, but the way that we're going to focus on is by elimination. Elimination will work a whole bunch of the time. So if you're only going to learn one way to do it, this would be like the most effective way to use, or to use. So anyway, the elimination literally means eliminating one of the variables. So we do that here by adding the two equations together. Notice there's already a negative 4x and a positive 4x, so I don't have to change anything in my equations. And when you add those together, those two things will just cancel out, or they don't cancel out, they become 0x, and then 0x is unimportant. So your x terms go to 0x, negative 2y plus 8y is plus 6y, and then negative 12 plus negative 24 is negative 36. And then your 0x is unimportant because it's just adding 0. So what we really have here is 6y equals negative 36, and now I can solve that for y. So I divide each side by 6, and I get y equals negative 6. So my answer is a set of coordinates, an x and a y coordinate. So y equals negative 6. And then at this point, I would have you go ahead and do this up to here on this problem right here. So if you want to pause for a second and do that, and then come back and see if you're right. Okay, so I have negative 6, positive 6. If I add those two things together, I get 0x. 5y plus 4y gives us 9y. And then 1 plus negative 10 gives us negative 9. So again, the 0x is unimportant because it's just adding 0. So I'm left with 9y equals negative 9. If I divide both sides by 9, I get y equals negative 1. So my y coordinate here is negative 1. So now I'm going to try to switch pen colors here so that you can tell the difference between my two work. Okay, that works. So now what I'm going to do is I'm going to take this negative 6 and I'm going to put it into one of these equations in place of y. Now you could do either equation. Doesn't matter which one you do. As long as you do your work right, it'll come out the same. But I prefer to work with as many positive numbers as possible, and this has a positive 4 and a positive 8. So I'm going to work with this equation here. So I've got 4x plus 8, but now instead of writing y, I'm going to substitute negative 6, and that's still equal to negative 24. So now if I work that out, if I simplify that, that's going to be minus 48. 4x minus 48 equals negative 24. And then I go ahead and add a 48 to both sides of that equation. So 4x equals positive 24. I divide both sides by 4, and I get x equals 6. So my x coordinate over here is 6. Now if I put a 6 back in here, I get negative 4 times 6 is negative 24 minus negative 12. So negative 24 plus 12 comes out to negative 12. So that works out. So now you go ahead and pause this and try to complete this portion over here on your side. All right, so I went ahead and started the equation over here. I rewrote this second equation. Like I said before, you could go up and do in this one here. I just like all the positive numbers. So I've got 6x plus 4 times negative 1. So I replace the y with a negative 1 equals negative 10. And so I'm going to simplify that, and 4 times negative 1 equals negative 4, and that equals negative 10. So now I add a 4 to both sides, and don't make the mistake I made the first time. This is not 14. Negative 10 plus positive 4 leaves us 6 negatives left over. Divide both sides by 6, and I get x equals negative 1. So these two problems came out with really similar coordinates, negative 1, and then 6, negative 6. It's not always going to come out that way, and sometimes you might get a fraction, sometimes you might get a decimal. It just depends on, what equations you're starting with. But just to recap, add your equations together to eliminate one of the terms. We could have eliminated the y term if that had worked out that way. Tomorrow we're going to look at some where you don't have, notice how we've got like a 9 and then a negative 3, and we have a negative 4 and a 1. So we've got to look at what you can do to alter your equations so that you can eliminate. But here they were already set up for us where we could eliminate one of the terms, which gets us down to an equation with one variable that we can solve. Solve for the first variable, go substitute that variable back into one of the equations, and then solve for the second variable. Now, if we were to graph these things, it would look something like this right here. The red line here is negative 4x minus 2y equals negative 12, and then the blue line is 4x plus 8y equals negative 24. And if you notice, so the red line is all of the solutions to the first equation, all the combinations of x and y coordinates that would equal negative 12. And then the blue line is all of the solutions or all the combinations of x and y that would work out in the problem to negative 24. They have one solution in common, which is right here. And if we take a look at those coordinates, we see that it's at 6, negative 6, which is the solution that we got for our first system of equations. Now, if I take these equations off of here and I put up the second system, negative 6 plus 5y equals 1 and 6x plus 4y equals negative 10, I find that I have a solution right here, and that solution is at negative 1, which is the x and y coordinate that we found when we solved that system of equations. So where the graph of two functions or two equations intersects, and it might be if you have a situation where it's not just lines that you're graphing, but say like a parabola, you might have more than one point of intersection, but wherever those two graphs intersect is a solution that they both have in common. I hope you found this incredibly informative. And if you were out of school today on the 6th, you will want to also watch the video for the notes on completing the square. So make sure that you do that also.